In this lecture, I will talk about features of Java that are called as buzzwords. Some of these features are the topics in this course, like multi-threading is a topic, a big topic in course. Anyway, it's like an introduction. We will go through these features. The very first feature is Java is simple. They say that Java is simple. The reason of saying it's simple because a programmer, if he's coming from C or C++ programming, then he find the syntax of Java similar to or C or C++. And even if you're learning Java as your first programming language, then it is not much difficult to understand. It is more simple, just like English language. Now, next thing is secure. Java is secure. The reason of calling this as secure as it cannot get viruses infected by viruses, or it cannot be attacked by any malware. The reason is Java virtual machine that we have studied about it. It is having a security manager or a verifier which verifies Java code and confirm that there are no bugs in the code, or there is no malware, or there is no malicious code in Java. So JVM will not execute if there is any malicious code in your program, or any malicious code is trying to harm your program. So Java runs within the shell of this JVM, so it is secure. See, we already saw this diagram that Java programs run inside here, JVM. So this will take care, and this provides security to Java program. So that's how Java is secure. Now next is portable. We have learned about platform independency feature of Java, that Java programs can run on any platform. So if you have written Java program on Windows, then you can port them on other platform like Linux and you can run them there. So Java can move on from one platform to another platform. So that platform independency brings in portability feature in Java. See, we saw this diagram that Java program once compiled on any operating system, it can run over Windows, it can run over Linux or Mac, on any operating system it can work, provided JVM must be there. So that's how Java programs are portable. So this is over. Now let us look at object-oriented feature of Java. Object orientation is a style of programming. This is a paradigm, a method of developing applications. And the principles of object-oriented programming are abstraction, encapsulation, inheritance, and polymorphism. We will learn about all these features. This comes under basics of Java programming. We will learn about this one. So it is object-oriented. So object-oriented languages are very easy to learn, and they look more like English language. That's how Java becomes simple. Now next is Java programs are robust. Robust means they are strong, they never fail or they never crash even in worst conditions. So what are worst conditions? During the runtime, if a program requires any resources and the resources are not available, usually programs crash. The programs of C++ may crash if they are not written properly. But Java guarantees that even if there is unavailability of resources, the program remains executing. It may not crash unless and until a user stops the program. So this feature is achieved by using exception handling. This is achieved using exception handling. We have a section on this one. We will be learning detail about this exception handling. So Java programs are robust, strong. Next is multi-threading. Java supports multi-threading. Multi-threading means we can break a single program into multiple pieces so that they can run simultaneously. We have to learn more about this one, multi-threading. So just name is sufficient here in this lecture. So Java is multi-threaded. Next is Java is architectural neutral. So it is architecture neutral means it is hardware architecture neutral. There are various hardware architectures, right? So the commonly used architecture is von Neumann architecture. There are other architectures also available. Commonly we are not aware of them, like the Most famous one is von Neumann's architecture. All the computers, all laptops, machines that we are using today are based on von Neumann's architecture. So Java runs on von Neumann's architecture. ARM is an architecture that is used in mobile phones. The processors in mobile phones, they are based on ARM architecture. So this architecture is a little different from von Neumann. If you want to study it, you can study it. But the hardware is of ARM is not exactly same as von Neumann. It's a variation of von Neumann, or it's somewhat different from von Neumann. Next is RISC, that is reduced instruction set computer, and ARM is based on RISC architecture. And there is one more, complex instruction set computers are also there, and embedded architecture is also there. So if you are interested, you can study more in detail about these architectures. So the commonly used one is von Neumann. So Java can run on any architecture because Java is not dependent on hardware. Java runs inside its own JVM. So if JVM is available on any hardware, then Java can run there. So that's how Java is architecture neutral. Next is Java is interpreted. We know that Java uses interpreter as well as a JIT compiler. Already have explained you this one. So Java is interpreted language. Being an interpreted language, Java is little slow compared to C and C++. Now in the beginning, early versions of Java, programmers were complaining that Java is very slow. So later on, they introduced JIT compiler, which made Java faster. So though it is interpreted, it is high performance. So this is a feature. So this is together. It is interpreted, but it is of high performance. It has to be understood like this. Then next is Java is distributed. So Java supports distributed computing. So this is a picture of distributed computers, like multiple computers are connected together in a network. And the programs running on these computers, they may collaborate together and work as a single computer or single software. They may work together as a single software. So a Java program can be divided into multiple components, and the components can be deployed and execute on various computers, different computers, and all those components together can work as a single program. So this is called as distributed computing, and this is mostly useful in businesses which are spread across the globe or across a country, where various branches of a business are working together as a single business. So the computers around the world may be connected together via internet, and Java programs running on various machines, they work together. So this type of applications are called as enterprise applications, and there are technologies that are supporting this type of feature from Java that is commonly used one. The old one was EJB. Now we have Spring. This is used in developing distributed application. So this is the presently used framework for developing distributed application using Java. Then lastly, Java is dynamic. So every object that you create in Java is dynamic because it is created in heap. That is one meaning it makes. And the other meaning is that if Java application is running here at one place, then you can easily move the running state of a program on another machine. So you can run the same program there. So it can transfer or port a program which is in running state. So this brings in portability also, and that portability is dynamic. So you don't have to shut down any component and move it there. So you can move the running form of the program from one machine to another machines. So anyway, this has very vast meaning. It can be taken in many various sense. So that's all. These are the features of Java. So I have just given the introductions, and some of the features require more in-depth knowledge, then you can understand them thoroughly. So that's all in this lecture.